Welcome everyone to Plastics Frontiers webinar series. The Plastics Frontiers webinar series was developed by the collaboration between the Royal Australian Chemical Institute, Society of Plastics Engineers Australia New Zealand and Society of Chemical Industry. We are thankful for the sponsorships from BSF Australia, Reckitt Benckiser, Qenos and Foundry Intellectual Property. For any concerns, please reach out to RACI. We are also thankful to the organising committee, Gary Bowman, Chair of RACI Industrial Chemistry and Dr. Yvonne Ma, Han Michel, President of the Society of Plastics Engineers Australia New Zealand and Dr. Steve Petanakis, Jenny Sharwood, OAM of the Victorian Education Committee for RACI and Dr. Richard Twitz, also Chair of Society of Chemical Industry. The purpose of the series is to highlight the continually evolving role and important contributions of plastics in society, some key societal and environmental issues faced by the plastics industry, and how the industry is rising to these challenges with new innovations and practices. With our backgrounds in education, industry, and academia, we are reaching out to as many sectors ranging from secondary chemistry teachers and students to researchers and innovators in industry and in universities. We hope you enjoy this series. Thank you for watching.
Okay, good evening, everyone. And welcome to this evening's RACI webinar series, episode 6. The topic of this episode's seminar is industry voices. So we have 3 speakers lined up from industry. We have Robert Moran from LyondellBasell. We have Jeroen Wazenaar from Qenos, and we have Daryl Farrow from Withdale Plastics. So our first speaker this evening is Robert Moran. Robert is a business manager for LyondellBasell Australia. As business manager, he is lead for product development, product stewardship, marketing and sustainability. With a 30-year career in the chemical industry, Robert originally worked as an analytical chemist in his early days and joined LyondellBasell and has worked in diverse areas of the business ranging from polymer science, technical service, sales and supply chain. Let's welcome Robert. Thank you, Robert.
Thanks, Steve. Look, please don't ask me any questions related to analytical chemistry. I'm quite rusty in that area, but yeah, thanks and thanks for having me here. Really honoured to be able to present to you some of the things LyondellBasell Australia is working on in the circular economy. Firstly, I'll probably just give you a bit of a rundown on my organisation. It's a global organisation. We've almost got 20,000 employees. We manufacture in about 22 countries and we sell to over 100 countries. We've got some pretty good positions in compounding and licensing. So a lot of our competitors use our technology for manufacturing polypropylene and polyethylene. And we also have a range of intermediate chemicals that we manufacture. We have refining capabilities in the US, and globally we manufacture polyethylene and polypropylene. In terms of our approach to sustainability as an organisation, I would welcome anyone to read our 2019 sustainability report. My understanding is probably in June, there'll be the 2020 version being released, but we've made commitments to globally produce 2 million tonnes of recycled and renewable-based plastic polymers. We have committed to 100% reuse, recycling, recovery of plastics in packaging by 2040. And we are a member of the Alliance to End Plastic Waste, so a founding member. We also have our CO2 emissions targets, 15% reduction by 2030. And we are very safety conscious, as most organisations are, but we have a program called Goal Zero, which is really aimed at safety and environmental incidences at a zero level. I just wanted to give a little bit of a feel for what we're doing globally, particularly in Europe at this stage. We've just recently announced a new brand trade name range. We typically produce grades that are either Hostelin or Mocklin, or whether if they're stiff, they're called AdStiff. If they're flexible, they're called AdFlex. So we're very imaginative in that area. But what we've got now is a range of products called Circuline, and there are three fundamental Circulines. One is Circuline Recover, which relates to mechanically recycled plastic. Circuline Revive, which is about the advanced recycling of plastic waste, and that's something I want to cover in this presentation today. Both Circuline Recover and Circuline Revive concepts here in Australia. And a third one, which is Circuline Renew, which is to use materials, renewable-based sources to produce polyethylene and polypropylene. How does it all fit together? This diagram really does capture it well, I think. If you look at the right-hand side, or my right-hand side, I should say, at the consumption and waste collection area, some of the plastic waste could go to energy recovery. There is some going to landfill. But if you can, once you sort that out, you can divert them to a mechanical recycling stream. You can also divert it to an advanced recycling stream. Now, if you've got both of those operating well, you should really have a potentially zero landfill for the polyolefins, that is polypropylene and polyethylene. What I would say is we're developing our own technology, which is the Moritech technology. We've got a pilot plant in our research centre in Ferrara, Italy. Also, you can see coming into the production area, the Circuline products, which are based on bio-sourced renewable content, and what that basically feeds into the conversion technology, which are typically our customers. I just wanted to say that we're avid supporters of APCO and the targets, and we also think that the new and expanding ARL, Australasian Recycling Label program, is going to really help with getting the right sort of feedstock into the right bin, into the right sort of areas. So we support the 2025 national packaging targets. We are an award winner. So we won in 2020 the Sustainable Packaging Excellence Award. It was disappointing not to be able to get to the award. It was done remotely for us. So we have really worked hard on our packaging solutions to our customers, and so we've won that award. We're pretty proud of it. Just a brief overview of what we do within our product portfolio. So obviously, over decades, our customer base and in fact the plastics market here in Australia and globally has been looking to reduce, looking to down-gauge and use less material, and we've done that through two main fundamental areas of product development. We've made stiffer materials that still maintain their impact, and we've also produced lower viscosity materials that helps those that injection mould produce parts at a faster rate, so you can get more out of your machine. We supply into the durable applications area, so that's part of the reuse and repair section of the waste hierarchy, and we are progressively and increasingly playing more in the mechanical recycling and advanced recycling space. So advanced recycling has also been is also known as chemical recycling or feedstock recycling. I should just sort of say that when we talk about chemical recycling, there's really only one kind of concept that is practical for the chemical industry, and that is this sort of recycled or renewable attribution concept. this is based on the mass balance, and so this is where you are basically running a system which is using conventional sources of input. These are generally in our industry derived from fossilized sources, and they're non-renewable. But what you can do is you can add renewable resources into that stream, and you can just identify them through a mass balance process. The ISCC Plus, which is a certification system for renewables and chemicals, illustrates this really well. So if you've got 3 inputs on the left-hand side, and you've got a renewable input, which is input A, what you can do is you can take out 1, 2, or 3, or many products and attribute it to them, so long as you don't exceed the mass balance. I think that's a really good sort of background when we are talking about the case study that I want to show you. So we're involved with a number of other companies in looking at a feasibility study in the sort of Geelong-Altona petrochemical corridor. The other companies involved are Nestle, Coles, Licella, IQ Renew, and Amcor. I just want to briefly talk about the Licella technology. It's a plastic waste to oil conversion technology. So it is an advanced recycling technology. It uses near supercritical water. It is what is termed as hydrothermal cracking, and the technology is termed CAT HTR by Licella. Now, Licella are an Australian company, and we've been working with them for a couple of years, and we've just started this feasibility study earlier this year. We hope to complete it by around mid to end of June. Once we've completed that, we'll be looking at the opportunity and possibility of investing in this technology for the Australian petrochemical market. So they do have a pilot line, and we'll come to what we've done with that pilot line as a demonstration. But a full-scale single line will take about 20,000 tonnes of plastic waste, and we'll convert it to about 16,000 tonnes of oil, synthetic oil derived from plastic, and that's a per annum output. So these are the partners within the supply chain of this feasibility study. So we've covered quite a sort of broad area of that supply chain. Involved also is IQ Renew, which is a partner of Licella. As I mentioned, Coles, Nestle, and Amcor. So all of these partners have industry funded this feasibility study. As I mentioned, it's looking in the Geelong-Altona petrochemical industrial corridor. So LyondellBasell's I guess objective here is to secure feedstock for advanced recycling at its Geelong site, which produces polypropylene. I just wanted to just run through, you may have heard of this in the press. We've got a bit of press coverage on what we've internally called Project Kitkat. And the name kind of gives away what was actually done. And so this was, I should say, this is a demonstration. So we didn't, none of the organisations are yet certified to either ISCC Plus or any other type of program. So the materials weren't put out there for sale, but it was really to demonstrate the process. And we actually went through what I'm about to show you, but it involved these 9 organisations all collaborating to eventually produce a Kitkat wrapper that had mass balance attributed 30% recycled content. Now, as we would imagine and can kind of guess, these sort of types of flexible packaging are not really that easily to either mechanically recycle or any other type of recycling program. So chemical recycling or advanced recycling really lends itself to this. So where did we start? Well, there were two collection programs. We're quite familiar, I think, with the Red Cycle program that's at Coles and Woolworth supermarkets, where we can take our soft scrunchable plastics, flexible plastics to the bins on a periodic basis, which is basically every time you probably go to the supermarket. And there was a trial that was being run and supported by Nestle and IQ Renew, which was the curb cycle program, which is whereby you would put residents were asked to put and volunteered, and there's been a really good response, but put soft plastics into a dedicated plastic bag that was sealable, and this would be put into your typical recycling bin or the yellow bin, and then it would be collected at the waste manager. In this case, it's IQ Renew. So they would sort out all these soft plastics, and you can see in the background other types of plastics, more rigid plastics that are baled. But this is a collection of the trial material. So we took that material and sent it to Lysella, who then in turn shredded the material and then processed it through their reactor systems. And you can see those reactors on the left. There's three large columns, and from the high temperature, high pressure water environment, we're able to produce oil. That oil we transported, which is from the Central Coast in New South Wales, we transported to Viva Energy Australia, and you can see there the oil, picture of the oil, and it's being dosed into the refinery. And we dosed that into the refinery, and we measured its mass, and we mass balance attributed it to oil, which was then attributed to propylene gas, and LyondellBasell takes that propylene gas from the refinery and polymerizes it to polypropylene, which is what you can see on the right. That polypropylene was then taken to Tagleaf Industries. Once again, this is all through a mass balance process. Tagleaf Industries produced metallizable film, which would be spec'd for a eventual Kitkat wrapper. That film was then further processed by Amcor, which went through the process of putting on the printing, the cold seal, and other type features within the reel. And then that was then taken to Nestle, and they went through the process of packaging the Kitkats. And so on the label, you'll see here, this is really, it's really meant, so it didn't hit the general market. We really have just used it for publicity in the industry, and it, and obviously highlighting to federal and state governments what we've done here. We've got a very good response. I will say that I heard a story that that Nestle had received some interesting Facebook responses, and there were some people that were very concerned that the chocolate was made from recycled plastic. So I can assure everyone that it's the wrapper, but to just show you, this really does highlight, and I think we've learned a lesson that the labelling of what you've done is really important, and the ISCC Plus has very specific labelling. And so, the labelling that would, upon certification, go onto such a product would indicate that the material was made from recycled content that was sourced from a mass balance process. That's pretty critical because it's not a segregated process. We haven't stopped the refinery and then put the right feedstock in and then start it up again and run it as a segregated process. This is utilising existing technology, and I think they sort of do this because at some point in time, maybe all the feedstock would be from recycled content. That would be the ultimate. So this is another picture of the. We had a launch, which was called the Wrap on Soft Plastic, put on by Nestle, which invited all many competitors and industry players just to participate in the launch of this event. So it's quite good. Yeah, I want to move on a little bit to, I've spoken about advanced recycling or chemical recycling, but wanted to just talk about what we might be doing or are doing in the mechanical recycling area. So we do have a project that we're working on at the moment. It's called waste saving water. And it's basically what we're looking at is these sort of polypropylene takeaway containers. This is a big part of our market. And we're looking at how we can create a recycling stream for these types of products. And the project basically is supported by Earth Champions, which is an international environmental charity. It involves obtaining these takeaway containers and converting them to water-saving infrastructure within urban environments. So these are the companies that are involved. We've got Nextech Atlantis, which is the manufacturer of the infrastructure, and we're involved as well. So we're supporting this project, and ultimately we've got kind of grand plans. First of all, we want to see this sort of linear recycling stream occur. Which we would set up a collection, a cleaning and a recycling, and then a second life manufacturing program. But also we need to take off a feed and start to experiment with cleaning it up even further to a food contact state, and then potentially putting it in at our plant in Geelong at potentially a 30 to 40% level. These are some of the infrastructures that exist. You've noticed this has got one of the pyramids of Egypt in the background, so it's clearly in Egypt. But this is what that sort of water-saving infrastructure looks like as it's being built. Here's something in New South Wales, another type of system that's occurring here. So what we are planning on doing is setting up a demonstration of the collection and then creating a particular infrastructure project. So I think that's coming along there. So I should say that we are really looking at a number of programs in Australia where we're sort of exploring collaboration with waste managers. And I can't really say anything at this stage as to what areas we're working in, because we're still in that development stage. But I can sort of point to what we have done in Europe. We have a joint venture with Suez, which is Quality Circular Polymers, and we have two organisations that are dealing in two areas. One is the waste area and one is the polymer manufacturing area, and we've collaborated, and we think collaboration clearly is key to success. And it's a 50-50 joint venture, and I just wanted to show you a typical grade range. You can see that the materials are grey or ivory. They're all based on ethylene and polypropylene post-consumer waste. I think I'm probably getting close to time.
Yeah, that's right. Yep, all good. Yep. Thank you.
All right.
Thank you. That was a great presentation, Rob. Lots of exciting new developments happening, and it's certainly good to hear that you're looking at the Licella technology very closely, and also it's good to hear that you're considering recycled polypropylene for food contact applications. That's certainly a bit of a pain point where I'm based at PACT. A lot of customers are asking us about what's happening with the recycled polypropylene. Can we get a food grade resin? So just before we move on, can you just comment about that aspect, how's that going to be done with LyondellBasell? Is that going to be a mechanical recycling process, or you're basically going to do like a advanced recycling for RPP?
I think we firmly believe that, you know, both advanced and mechanical need to be looked at hand in hand. They're complementary. So we would think if you consider the waste hierarchy, as you move down, you should avoid, you should reuse. But then we think in terms of recycle, mechanical recycling fits above advanced recycling. So if you can mechanically recycle something, you should. And then for those materials you can't mechanically recycle, then you should go towards an advanced recycling route. So these are the, I guess, if you were looking at a MRF or a PERF, these could be perhaps the red cycle content of their collection. It could be kind of tailings and sort of offcuts and waste, really stuff that is just, you know, really small materials, the broken caps and all that sort of stuff that could go into a chemical recycling process. And so, you know, if we can get really good source separation and cleaning, then, you know, ultimately a mechanical recycling route. I think food contact is going to be a big challenge for mechanical recycling.
Yeah.
I think if you look at the, you know, if you take a look at the, you know, what the no objection letters coming out of the, you know, that people publish and put online, that the US FDA has given, yes, they do get FDA compliance, but a lot of it is restricted. It's not, you know, for type and for conditions of use. So you don't have that flexibility. So, I mean, I think the technology is going to improve. There's you know, there are great companies like Nextech that are working in this field, and I think it will improve. But I think advanced recycling has a really important area to, you know, a really important role to facilitate that and get there earlier. And then I think, you know, the mechanical recycling for food contact will hopefully catch up.
Yeah, look, I tend to agree with you. Thank you, Rob. I think we'll move on. But before we do, just a quick word from me for our sponsors for this evening. These sort of events are not possible without the generous support that we receive from our sponsors. And these include RB, BASF, Qenos and Foundry. Thank you to all of them. And without further ado, we'll move on to Haroon Wazanar. So I'll read his biography. So Haroon is the market segment manager for pipe, dairy and blow molding applications at Qenos. He has a PhD in chemistry from the University of Amsterdam, specialising in catalysis. Prior to joining Qenos in 2017, he worked for 7 years in the polymers business of Total in Belgium in several roles, covering R&D, technical service and marketing. Next to his marketing responsibilities, Haroon is coordinating Qenos' strategy development in the circular economy space. He has developed an understanding of current mechanical and chemical recycling technologies and how they could enable Qenos to use waste plastics as a feedstock. Thank you.
All right, thank you, Steve. Let me try and bring my screen up. Okay. All right. I hope that's visible to all of you. Thank you very much, Steve. Thanks also to the organizers of this webinar series for having us on board and contributing to this session on industry voices. So my objective is to give you a bit of an overview of what is actually advanced recycling, what's the state of the art, what is feedstock recycling, and I think Rob here already touched on many of these points. I'll probably go just in a little bit more detail on those, and then finally hopefully touch upon what does this mean for Australia and how does that fit in the Australian context. So before I go into that, let me just start with a challenge. And I think the challenge that we're facing today is that plastic packaging only contains 4% of post-consumer recyclate. And this is in quite stark contrast with the APCO targets that we have of about 25 to 30% already by 2025. Now, I firmly believe that advanced recycling is a pathway to lift this. But in order to describe this challenge in a bit more detail, just let me go through the types of packaging that we're having today, how these are collected and recycled, and where advanced recycling really can come in. So looking at the rigid packaging, I think we can distinguish probably two classes. I would say the first one is the kind of more easy to recycle containers. So these are typically your PET bottles for beverages and your HDPE milk bottles. So a high proportion of these are being collected through the curbside recycling system. And there are technologies out there that actually can convert these waste plastics back into new raw materials that are actually food contact approved, and the examples are there with PET and HDPE, and we're certainly seeing those capacities ramping up. Now, this would be a kind of packaging material waste stream that you wouldn't think of doing anything other with than doing mechanical recycling. As you kind of move then to kind of more difficult rigid packaging formats, you're basically talking about colored materials. And as soon as you kind of introduce color, it becomes a lot more difficult to recycle it back because, well, the only option that you then have is basically a gray. So very quickly you start to look into kind of downcycling application, durable products, which of course have a value, but if you're talking about circularity, you will not achieve that with those kind of recycling options. And so potentially advanced recycling could be a pathway for those plastics to kind of come back at the top end of the value of the plastics again. Flexible packaging, obviously even more of a challenge today in terms of recycling. I think also in terms of the collection, innovation is required, and luckily we're seeing that. I mean, I think Rob, he briefly touched upon the Kirby project. There's of course the red cycle bin already, but I think, yeah, we really need something that is easy for consumers to understand and to use to really get the volume through of these soft plastics. And I think an important part is also, yeah, there needs to be an end market for that as well. We're seeing some applications in builder's film, for example, for these plastics. But again, this is all very kind of low value application, and markets like that will become very quickly saturated if you start to put very large volumes through. And I think there as well, as the example from Rob already showed, that advanced recycling is certainly there, a way to go to tackle this. So I think especially for these harder to recycled waste streams, waste plastic streams, advanced recycling is a really great way to go all the way back to your highest value polymers with food contact. Okay, so advanced recycling. So we believe this complements mechanical recycling, basically by upgrading heavily contaminated waste plastics to virgin-like quality. So let's first step back and look at the kind of traditional way we make polymers, specifically polyethylene and polypropylene. So we start typically with a fossil feedstock. Now this might be a naphtha coming out of derived from crude oil, or it could be ethane gas directly, which goes into a steam cracker, for example, where you're making the monomer, which is ethylene in the case of Qenos's operation, and we polymerize that to polyethylene. This then gets converted at packaging converters or other plastic converters into products that are being used, and in the kind of old traditional linear economy end up mostly in landfill. Luckily, we do have, of course, already recycling implemented and is working the mechanical recycling. So I'll not dwell on that. This is quite well established, but as we know, it's not capable of dealing with all the different waste streams. And so I think in the schematic there is a rest fraction that would be there from the mechanical recycling that can be further treated, and this is basically where we see advanced recycling coming in. I would see advanced recycling as a general term that actually describes a multitude of different recycling techniques. And they actually then bring the material back at different stages in this kind of value chain. So the first one will be feedstock recycling, where you're taking a mixed plastic waste and you convert it back into a feedstock from which you can make new monomers. Now there's two main ones here. The first one is gasification, where you basically break down mixed plastics into syngas, which is a mixture of hydrogen and carbon monoxide. You can use that as an input to make, for example, methanol, which is a platform chemical from which you can derive many different chemicals and polymers. Probably in the Australian context, I will not dwell on that too much. You need certain kind of infrastructure that we don't really have here. It might work in places like northern China, potentially in South Africa. But I think in Australia, we don't really have the rest of the chemical infrastructure to deal with the output of a gasification plant. And so therefore pyrolysis, which Rob already touched upon a little bit, and I will go into a little bit more detail after this, is a better way of feedstock recycling. I also wanted to briefly touch upon depolymerization techniques, which basically brings your plastic waste back to a monomer that then can go into polymer production. So this is actually quite neat because you'll have relatively high yields of that. You don't make as many different products as you will see that you make with pyrolysis, but it is only applicable to a number of different polymers. So it works for PET and is being commercialized there, and it works for polystyrene as well, and we're seeing that process also being commercialized. However, for polyolefins, polyethylene and polypropylene, this technique is not really applicable. Thirdly, which is also kind of grouped in this advanced recycling, we're seeing kind of purification techniques. Examples are CreaCycle by Unilever and PureCycle by Procter & Gamble. These techniques basically try to dissolve either the polymer to remove the impurities or dissolve the impurities to purify the polymer. In any case, you're trying to do some kind of dissolution to extract the polymer and then precipitate it afterwards, removing any kind of contaminants. And so this is applicable to a number of polymers. I think it's been demonstrated to work for some polypropylenes, and I think for some polystyrenes as well. It's quite specific though, and you have to start already with quite a pure, at least a monomaterial stream mostly, in order to make that effective. So I think the widest applicability in our context is probably feedstock recycling in the form of pyrolysis. And so let's look at that into a little bit more detail. So pyrolysis is able to treat mixed plastic waste to generate liquid and gaseous feedstock for polymers. So what kind of mixed plastic waste can it actually treat? So it is ideally suited to polyolefins, which means a mixture of HDPE, LDPE, and polypropylene. It can deal with some other polymers like PET and polystyrene, but they need to be in low percentages. They will basically not generate kind of the desired feedstock for making new polymers again. The key one that one has to take out is PVC. PVC in this process would be generating hydrochloric acid, which could corrode the installations and also create all kinds of molecules that are not really suitable for further treatment, and should be really removed. You could argue it should maybe not have a place in packaging at all, but I'll leave that to the packaging designers. So this mixed plastic waste feedstock is then fed to a pyrolysis unit. Now there are many different type of reactors being used. One example that Rob shared was about the Lysella process, but there's dozens of different technology providers that have their own pyrolysis technique using catalysts or without using catalysts. Principally, it's operating at a high temperature between 400 and 650 degrees. importantly in the absence of oxygen. And under these conditions, long chain polymers, which are hydrocarbons, are basically being converted, chopped up into smaller molecules. And what you end up is basically a soup of much smaller hydrocarbons, a little bit similar to basically making a crude oil again. I've given you some typical product distributions. About 20% usually ends up as a gas, 70% is an oil, and there's typically about 10% of a char that remains. Some of the gas is usually used as energy recovery to fuel, to generate that heat for the process, and some of the char can also be used for that same process. The oil and some of the, let's say, the more complex gases, so not the methane, but the higher gases, ethane, propane, butane, after some purification, they could actually form quite a good feedstock for some of the cracker units that we have operating here. And some of the heavier oils, they could actually be a good feedstock for a refinery cracker, which typically deals with much longer chain hydrocarbons as a feedstock. So how would that then? So, sorry. This process is known for 30, 40 years, and there has been a lot of academic research into pyrolysis, but it has been very difficult to kind of commercialize that. And it hasn't really been until I think the last 2-3 years that there's a real success rate into commercializing this to use in recycling techniques. And I think the kind of commitments that brand owners have made, that governments have made, have been a real catalyst in the commercialization of that. And so on this page, I just want to show you a bit of the global rollout of pyrolysis-based feedstock recycling. And this is really accelerating. I think this list would have been very short had I talked to you 2 years ago. But we see basically at the moment, almost every week, a new producer announcing new capacity. We're seeing this capacity especially being built in North America with a couple of projects announced, some of them coming on stream this year, others in 2 years. And the other region where there's a lot of activity is in Europe, with basically all of the major producers there announcing capacity for advanced recycling through pyrolysis type techniques. I will not dwell on this further, but just to show you that yes, this is going from the lab into commercialization and going to commercial scale, even though there's still a long way to go looking at those capacities and comparing that with the annual demands for commodity plastics. So pyrolysis-based feedstock is optimally recycled back into virgin-like resin using existing refinery and petrochemical assets. So as we discussed, virgin resin is being converted into packaging and other products, is being used, comes back through waste management into MRF facilities. What can be mechanically recycled should be mechanically recycled, absolutely. But a part of it is ideal feedstock for a pyrolysis plant, which then can basically generate a lighter feedstock, which could be taken up by an ethane LPG steam crackers, as we operate, as Qenos operates in Altona and in Botany. And the heavy feedstock could be a very good feedstock for the kind of resid crackers or FCC units of a refinery, which then generates both LPGs and propylene directly that can be used by polyethylene or polypropylene plants. And the LPG can also be cracked in a steam cracker and generating ethylene and propylene. And so this way you can kind of then close the circle. And importantly, what you're making at this stage is absolutely, that has come through the cycle, is absolutely indistinguishable from the original virgin resin. All the properties are completely preserved in terms of food contact, in terms of mechanical properties. There's absolutely no difference. So the challenge then becomes, how do we really tell them apart? And I think Rob already touched on that. Mass balance is the key here to enable the allocation of recycled content by co-processing recycled feedstock in existing petrochemical plants. It basically would not be economical to build new plants and everything just to process recycled materials. I think taking advantage of the infrastructure that is already there really enables this to be an economic process. And so you're using basically a mixed input material, fossil and recycled input that is being used in basically a complex of refinery and petrochemical units, where it is then converted into products. Now, in the process, all the molecules are perfectly scrambled and intermingled, and you won't be able to tell which molecule is in which product. But through basically an accounting, mass balance accounting, that you know what's going in, you know what's coming out. You can't basically get more recycled content out than you put in. Plus, you have to account for any losses along the way, so-called conversion factors. You can actually make that work. And in order to make that transparent and build trust in that, third-party certification is really important here to make sure that the right thing is being done, and to create trust in that from brand owners and consumers. Now, are we helping the planet with that? There's of course, a lot of challenge to that, and data. There's not a lot of data on that out yet, but there's some preliminary life cycle assessments that have been published. And I'm taking here the example from Plastic Energy in Qantas, which is basically uses the European context.
Two minutes, Haroon. 2 minutes.
Okay, very good. It looks basically at two different ways. From a waste perspective, say I have a kilogram of mixed plastic waste. If I do feedstock recycling or waste to energy or landfill, feedstock recycling is better than waste to energy. The CO2 emissions are less than actually burning the plastic, and you get some credits because you're not needing to make new plastic. Landfilling, controversially, is actually a very good way, but it has a lot of other issues associated with it, and climate change shouldn't be the only parameter that you're looking at. From a product perspective, we're seeing that feedstock recycling is actually also giving you a better carbon footprint compared to virgin sources. While it generates a lot of CO2 to make it, you're actually replacing virgin material, and you're also making sure it doesn't go into waste to energy, which has a very high carbon footprint. Mechanically recycled product should be preferred, though, as it is much less energy intensive, and so has a better net balance in terms of carbon emissions. So that actually then brings me to the end and kind of the perspective of where this can go. We think advanced recycling of plastics in Australia requires new infrastructure to be developed, but also, very importantly, existing assets to remain viable. So I think there's a lot of work, and I mean, we're only playing a small part in this. Design for recycling will be essential. We need soft plastic collection, soft plastic sorting. I think mechanical recycling the capacity needs to be greatly increased. There's capacity needed for advanced recycling as well, and then also how to integrate that with basically existing assets. It's not as straightforward as it may seem. And I think lastly, we have to make sure that the plants that we have in terms of refineries and polymer units, that we keep those assets operating here. And it was, I think, some positive news there yesterday from the government for support for the refineries in Australia. So with that, I'd like to end my presentation, and happy to answer any questions.
Thank you, Haroon. great presentation. Thanks very much. And that was excellent news yesterday, announced by the government that they're going to support the refineries in Australia. I think that's it provides surety and continuity, and that's what we need right now in the industry. So I think we'll take questions at the end. So I'm just mindful of time. So we'll move on to our next speaker. So Daryl Farrow from Richdale Plastics. So Daryl has worked in the plastics industry for about 30 years. He started out as an engineering cadet with Transpac Amcor in New Zealand. He has travelled, he travelled the world for several years before returning to New Zealand to help start up a new packaging company. He then moved to Christchurch for 3 years, then on to Melbourne, where he has been based for the last 20 years. Daryl's plastic career has been mainly involved in barrier films and high-tech flexible packaging. This covers most industry sectors throughout Australia and New Zealand. Daryl is currently working as a product development technical manager at Richdale Plastics, with an emphasis on developing 7 and 9 layer co-extruded films. Major developments include recyclable barrier films, VSP films, breathable films, and recyclable, have I got this right? Recyclable DOI films, is that right, or Daryl?
Yeah. DOI packs, yeah.
Yep, got it. Over to you, Daryl.
Okay. Well, I'll just pull up my screen. Find it here. Where's it going? Yeah. Something's happened here. Just hang on a minute. Well, for some reason, it's not coming up. Not sure why, but try that.
Yeah, something's coming up now, Daryl.
Yeah, it's not working. I'll try this anyway. Is that working?
Yeah.
Yeah.
There might be a bit of a delay. So has it loaded on your end? Has the presentation loaded?
Yeah.
Okay.
Yeah.
All right.
Not coming?
Not yet. We can see your screen, but it hasn't loaded the presentation. There might be some delay.
Okay, something going on. I'll try again.
Yep.
Now?
All good. All good.
All right. Okay. Sorry about that.
No,
okay.
It's okay.
Yeah, look, I'm not going to, they were really, really good presentations from the other guys, and it actually is a very good summary on, I think, where we're really positioned in Australia and globally as far as polymers and plastics and packaging, and not just packaging, but all industries really. Richdale Plastics is quite a new company, and it's only around just over 8 years old, but fast growing, very innovative, spends a lot of money on new plant and equipment. So the backbone of this business moving forward is very strong on the innovation side of it, using the latest technology, you know, from our machinery partners like Windmill and Holscher and a few others, but primarily Windmill and Holscher. So we're sort of fast learning and growing and using the expertise actually within the business, and also with our partners around the world that we share a lot of technologies with, and that could be in the polymer side of it and also the machinery side, and just general packaging knowledge. We network with a lot of guys around the world to try and bring solutions, you know, to the table. So I'm going to talk a lot about that, and making like sustainable packaging. It's been spoken about by the other guys quite nicely, actually. So I've sort of summed up. I had 5 minutes to put together some slides. I've been out all day, haven't had time to really put this together properly, but you know, I've sort of put down some brainstorming points, creating packaging to be reusable, easily recyclable, and recreated, you know, for recycle. So removing packaging from the dump cycle. So that's primarily what we're trying to do, is really removing packaging and plastics from the dump cycle into dumps around the world. And when we can achieve that, that means we're actually working to our goals and we're on the right track. Reconstituting into safe polymers after consumer use has been mentioned, and in food packaging, I'm afraid, until we can really do that, it's probably going to be the showstopper for food packaging. It has to be. Compliance is getting harder and harder in food packaging. There's a lot more hoops to jump through. It's not getting any easier. So it's really important that we understand that, and packaging is got to comply. So I spend a lot of my time now on compliance and making sure structures actually comply. So, and that's working with resin companies very closely to pull information out of them. So, and reducing carbon footprints, we've touched on that as well. And a big part of it is going to be changing consumer mindsets. So there's a whole culture out there which has to change, with people's views on packaging and plastics, and most people don't even know, 99.99% of people don't know what plastic really is. And you know, plastic film that they see wrapped around, you know, their snack foods, or you know, cheese, blocks of cheese, or meat. They have no idea that some of those products are very, very sophisticated and highly technical. So to bring the product to the shelf. So it's really important that we're creating systems and packaging which can actually be easily recycled. Go back up to this top one here. And that's what we're trying to do here at Richdale Plastics, is changing structures that are really hard to recycle and make them a lot easier, so there's less energy required downstream to actually recycle, whether it's mechanical recycling or chemical recycling. So if we can get it right at that end, then it makes the other end a lot easier. So that's a lot of my job, is to bring that to the table and actually teach food companies how to do that. You know, it's not easy. Processing equipment has to change. There's got to be a rethink on how we actually do that, and how some of these flow wrappers work, vertical form, fill and seal, pouch filling machines, all this, they all have to be modified. So it's really important to understand that as well. So yeah, the healthy, sustainable life cycle, the other guys have been through that. I think it's really important is to create, down this point here, well thought out collection systems, right? This is where it's going to be really important, is creating a collection system that is it's workable, because out in the real world, people will soon work out whether, you know, that's going to be achievable for them or not. And so I think, you know, looking at other parts of the world and how they've actually created and designed their systems is a good place to start. And I think Australia is sort of going down that path. But there needs to be a lot of effort go into it, and this is going to be really important. So world's best practice recycling systems is going to be needed. And, you know, it's like everything evolves, you know, just like the automotive car has evolved over the years, you know. The world's best practice recycling systems will evolve, and in 10 years' time, they'll look even more different than what they are today. So it's just a matter of putting the time and effort and the money into it. So now packaging to incorporate PCR, post-consumer recycle easily and safely into the products this is the challenge, right? At the moment, PCR, as we know it, can't be put, and most big food companies won't go near it for safety reasons, health safety reasons. So, you know, I can design a structure which you can put that in there, but you know, it's not cheap. So everything has to be costed, consumed. Well, companies aren't going to pay huge amounts of money for, you know, structures that, you know, aren't going to be commercial. So and then, so this is touching on this compliance side of it here. So world safety standards, every country, you know, you've got Japanese standards, you've got Chinese, you've got European standards, American FDA standards. There's a whole lot of other standards out there for other countries as well. And all these polymer technologies have to comply. If you don't comply, you could be in serious trouble. So this is going to be really, really important. And this is a lot of my focus is all in this here. You know, to bring this PCR side of it in, it's going to have to pass this gate here. So that's a really important part of building a structure. Some of the processes that we go through and the thinking that we go through when we're building structures. So at the moment, most of our work is really using PCR is in non-food contact products, and it's quite easy to do that. Now, some of the packaging examples, if you look at packaging out there, this is just some of them, not all of them, but you got the polyethylene systems, you got the polypropylene systems, PET systems, then you got the new high barrier hybrids, which we're putting a lot of effort into, and you got your PET PE laminate replacements, the coated BOP, which is your PVC coatings. So I think it was mentioned that there's a question mark around should PVC be in packaging. I sort of agree with that in a lot of ways, because it's a dangerous unit. You know, when you have to recycle it, it produces some nasties there, which most of us know, and so does, you know, PVC coated film. So classics are your coated BOPs, your coated PETs, and your coated nylons. So they're the three prime ones, which in flexible packaging is still used heavily today. So we've been very successful here at Richdale Plastics in actually replacing all of those three there. We can actually replace every one of those structures with a fully recyclable, whether you want it barrier or just non-barrier, product, you know, and it's very cost effective, and in some cases it's actually even quite a lot cheaper. So it can be done, and this is some of the examples. This one here, this is Sugar Australia. This is quite an interesting structure. It's a high barrier structure. It's a 7-layer. It can be run as a 9 as well. And that structure actually won an award. It actually won the Innovation Award at the last FPLMA awards night. We won that award with this structure, where we took this, the coated bot or coated PET PE structure, and we turned it into a surface printed 7-layer coax, and this structure is recyclable. So you can mechanically recycle this quite easily. And use it not in food grade, but you can certainly, you'll get a jazz, what we call a jazz coloured product out of it, with minimal contaminant. So, so it can be, you know, quite easily recycled and used. So that's low cost, low energy type recycling. So this is a real winner. And this product here, these are doys. These are the recycled doys that we've created. Now we did this as a bit of a promo, but this is very smart technology using it's very similar structure to the CSR sugar structure. And the fact that structure there will basically replace virtually every doy structure that you see on the shelf. And it's very robust. It's hot fill. It can handle boiling water straight from the jug, and stand up firmly, won't fall over. It'll actually perform better than a PET PE structure. It is ultra high barrier. You know, we've now got in development, and we've done a lot of tests on EVOH, I think is going to be a real game changer in high barrier packaging, with you know, some of the things that we're doing with EVOH, which I really can't talk about on here, but we're producing structures where you can have these EVOH structures in very high moisture atmospheres. Whether it's retort, you know, high-end retort, or in the tropics, and the EVOH will not lose its barrier. So it's just saying that statement is a game changer for a lot of packaging. And so what we're doing now is creating structures like, you know, these doys here as well, where we can prolong you know, the lifespan of food products on the shelf, which means, you know, you can make a product here in Australia, and you can ship it all around the world, and it's going to keep that food product in a very good condition. And with the added benefit that it's actually recyclable. So we're making here, it's being packaged in this packaging, which is then world class. It's certified, you know, it's internationally certified, and this is the key as well. So, you know, we can make a whole lot of statements. So what we're doing here also is to get our structures internationally recognized, and that's through international certification, which I think is a very good way of making sure structures actually conform. So you can have, you know, all your calculators and all that sort of thing, but until you have a structure that's internationally recognised, I would rather go down that track, because it's put under the microscope by a recognised and a certified concern. So that's the path that we're taking, because we want to build world-class, world's best practice in packaging and recyclable barrier packaging. And so that's a couple of products that we're doing. So, you know, things like organic stock, you know, this is an example, organic stock, so soups, hot fills, nuts, anything. You can put anything in here, and it will handle the application. So that's a good, very, very good example of what we're doing. Another one here is, so that was purely a surface printed system, right? Coax system. So there's no lamination or anything like that. It comes in zipper or non-zipper. So they're all fully recyclable as well. These here, this is just off the shelf, but what I did here is we created this coffee company here called Melbourne Coffee. And this was put together with a friend of mine. And this is internationally certified as well, the structure. And I think this is in for another award, actually, this here. But we built this here using OPE as the reverse print web. And we laminated that to an ultra-high barrier EVOH coax system. And this has got full international certification through SGS. And that there has been packed with coffee beans and valved, and that was run on an automatic machine. So, and it works very well. So we took a foil system, so nylon foil PE structure, and we've turned it into this fully recyclable high barrier system, which can be easily mechanically recycled into a jazz product, or it would be chemical recycling. This here would be quite easily broken down. So there's that one. It's quite exciting, this here for the coffee industry, and you can use this in any type of packaging, like replacing nylon foil PE type structures. This structure will actually do the job really well. So this is a real big game changer here as well. So this one here, So Soft, is a marshmallow company which is growing very fast and very successful here in Victoria. So privately owned. It's a really exciting company to work with, and we have changed their packaging from very poorly recyclable type packaging using coated box to PPs and PEs, and we're now using something which is a bit friendlier. We've taken the PVC coating out. The first stage for these guys is to go down this path and basically use our high barrier EVOH. Marshmallow requires a lot of barrier, believe it or not, to keep your marshmallows nice and fluffy and soft. It requires ultra high barrier packaging. So this was another really good success story in bringing their products to the shelf throughout the supermarkets in Australia, and that packaging can hold that marshmallow for a very long time without it going off, and without using PVC coatings. So that was a real winner, and that structure there can be used for flatbreads, anything that's using coated coated PETs or coated BOPs. The structure will do really well. And also, so what we do is we design all our sealants, right, for all these structures. You'll find we'll have to go up a level, right, because you want to put less heat into the structures. So we actually design all our sealants, and our standard sealant, we don't change. We keep it at a very high level, which means we can always be guaranteeing the customer a very, very wide window heat seal range on its product. So in most cases, food companies are reducing their temperatures and speeding up their lines. So
1 minute to go, Daryl.
Yeah, okay. And this one here, this is VSP, which we have already developed our own VSP film here in Australia. We're the only company in Australia that can actually do that. All this product has been imported into Australia. There's no need to do that, right? So we're what we're about to is building technology in Australia, so companies in Australia food companies don't have to import. So it's important to be hooking into this sort of technology, right? It's very smart. It's been around a while. It's used in meat. Woolworths is taking this on big time. This is not our product, but we'll be launching ours. And it's also being used in the meal market as well, right? So ready-made meals. This is some of the equipment that we use. Right, this is a 9-layer line, brand new 9-layer line, coax line, very high tech. So we've got a 7-layer line, 9-layer line, and it's started out. It's the best technology in Australasia. And then we've got our laminator, our press, and also have a number of slitters. So we have a very good combination of equipment to be able to put together structures which are fully recyclable, using technologies from all those companies that have been mentioned tonight, through LyondellBasell and Kunos and many others out there as well, ExxonMobil, Dow, SABIC, BASF. There's some really, really smart technology out there, and our job is to pull all those technologies together using equipment like this, and we can create some really smart solutions for companies. Okay.
Thank you, Daryl. Some interesting work happening in your area.
Yes.
So if I could just start off, you mentioned international certification a few times. I wasn't clear what you meant by that. What were you certifying?
Well, to get, say you've got a structure, right?
Yeah.
Now to certify that structure, so I can take that anywhere in the world, right? I can sell my structure up into Europe, right? So if I build a structure, I have it certified by, say, SGS, which are a certifying company, right? They do a lot of certifications for different standards. You know, they'll certify your company for, you know, HACCP or BRC or whatever, but they'll also certify your structure, so you can actually market that structure offshore or anywhere in the world as a recyclable structure, right? So we're all using the same methodology, right, around what is recyclable and what isn't, right? So the Australian methodology is not Australian. It's more European. It comes from the European stable, and so that's where we're going. And so when I say certification, we can put together a very complex structure, and we can say this structure here is fully recyclable. You can mechanically recycle it, and it will easily go into either a PP stream or a PE stream. They're the two main streams that we need to be aiming for. And so what we're doing is concentrating a lot on the PE stream, because that's where the dollars is. And most recycling guys know that the PEs will get you more value, you know, at the gate than, say, a PP. And so a lot of our structures, we then have to say, well, okay, how do we know that is correct? So if we're going to export some of these structures, we've got to have that certified and say, look, yes, that's correct. That is true.
Okay, so at the moment, if we look at the Australian context, so some of the products you showed us in your presentation, they have the ARL logo on them?
Yeah, the Sugar Australia have just finished putting all the ARLs on theirs.
Yeah.
So we recommend companies to use the ARL system. There's no issue with that at all.
And they would be recycled through the Red Cycle program? Is that how?
Well, Red Cycle, you can use Red Cycle, or like Red Cycle, you know, if you do the analysis on Red Cycle, there's very, very, very minimal amount of packaging going back through Red Cycle, right? It's very, very small percentage. And, you know, so that's why I'm saying we're in the infancy of recycling systems and collection. And so it's important, I think, to put systems in that work, right, and that people are going to catch on to and actually use.
So what sort of systems are you talking about, Daryl? Can you just make a bit of commentary around that?
Well, I think there's got to be a bit of a culture change, right, with, you know, collections. We have to have smart collections, you know, how that looks. Europe is a very good example.
No, I get that, but what's happening to the product as we speak?
What the?
Yeah. So what's happening? The products you just showed us in your presentation, how are they being recycled at the moment?
Well, they're offered through Red Cycle or.
So it is through Red Cycle.
Red Cycle,
yeah.
yes.
Okay.
Yeah, that's the only avenue that we have in Australia for soft plastics as such post-consumer.
So you're saying possibly in the future there's going to be another avenue for your products?
Well, I think if we're going to collect, right, if we're going, you know, I'm just brainstorming here out loud, if we're going to collect, there's thousands of tons of flexible packaging produced in Australia every year. Thousands of tons, right? We're covering, this company here covers agriculture, horticulture, mega amount of industrial type packaging. You know, we're a big concern in all those fields, and I can assure you we're pumping thousands of tons of polymers, and so it's important to get chemical recycling up and running. There's agricultural guys that are just burning plastics, dumping, digging holes, dumping, right, because they don't have any avenue to actually really deal with it. So chemical recycling is one of those avenues, and I think it's exciting for that side of it. So, and there'll be there's just thousands of tons of plastics used in that area every year. So yeah, look, and when you look at flexibles and food, and food's the same. So we need smart systems to be able to pull that together.
No, I agree with you. I'm just mindful of time, so I just want to open up the Q&A to the floor. So I've got one question at the moment. I believe this is for you, Rob. How widely available are the takeaway containers? This attendee has asked, all of the takeaway shops around my university in Victoria have switched to cardboard biodegradable alternatives. Yeah, I'm not sure what the question is there, but yep.
Yeah, okay. Well, look, there are alternatives for the takeaway containers. These are the sort of sugarcane clamshells or cardboard or PLA. In terms of biodegradable or compostable options, there's obviously a reuse option, which is of interest to us, but or I should say LyondellBasell. So in terms of the Australian market for these sort of takeaway containers, and these are the ones that you get your Thai food in, your Indian food, Chinese food. They're clear, homopolymer polypropylene. They have a lid. They come in various sizes, but usually rectangular or kind of a sort of circular, annular type shape, which is a tube type shape. And there's around, the market for that is including what is imported, but most of it comes from local production, Australian manufacturing. So the raw materials manufactured here, the containers are manufactured here, and there's around 20,000 tonnes per annum of that goes into the market. The alternatives are not derived from Australia. They're generally from Asia, particularly China. These are the sugarcane type pulp materials, and I don't think we manufacture PLA. I could be corrected. I don't think we manufacture that there. So when you do all of that and you take a life cycle assessment, I'm interested to see where that goes. I don't think that's being done. Where we find, interestingly, where we find there is penetration of these sort of bio type materials, because these materials cost more potentially have got a greater carbon footprint, and I'm happy to have a discussion with anyone about that. We find where my office area is in South Yarra is quite a good hotspot for that. And
Well,
also around universities, that's where, you know, universities have made pledges. They've gone, we're going plastics free. So the cafeteria is plastics free, and that's how they.
But that's exactly right. But not. But it's an interesting. We could be here all night talking about this subject, but it's just at the moment these alternative materials are perceived to be more green, when in actual fact they are not. So, and the classic one is the biodegradables. If they're not properly dealt with, you're actually contributing to greenhouse gas emissions. So anyway, this is another topic for another evening, but we'll move on. There's a couple of questions coming through here. So, Jeroen, if Altona is shut, does this remove the capacity for scale? Sorry, Han, have I got this right? AR in Australia, or can Viva handle the plastic crude? Advanced recycling, beg your pardon.
Advanced recycling, yeah, that's right. Yeah, thanks, Ed. Great you're listening. I know we have been exchanging quite a few emails. It's good to have you here. Look, I don't see Altona shutting anytime soon, and I do think Viva can probably handle a large part of it. There's probably just some of the lighter fractions that are probably not ideal for them, and that will be great feedstock for us. But I think more importantly, we're the only polyethylene manufacturers in Australia. So if you want to do advanced recycling towards polyethylene, it will have to go through us. I'm just reading the other questions there. Steve.
Yep.
Where pyrolysis takes more energy than it creates, can mass balance include energy inputs, that is RDF from waste, to create heat to drive polyolefin pyrolysis? At this stage, I don't think the mass balance approach actually allows for heat to be used as recycled content. Maybe in the future there will be more expanded versions where that would be allowed, but I think that will be treated as waste to energy, and it doesn't really matter too much where that energy is used. So I think at the moment, from the schemes ISCC Plus or Red Cert that I'm aware of, I don't think you can actually do that. And I see, yeah, Rob is nodding as well.
No, and a lot of the pyrolysis units basically take off a light fraction of gas and use it as its own energy source. It's a little bit like an extruder, where you get the extruder going, but then it can almost self-propel itself. So the pyrolysis does that because it utilizes some of the byproducts of the process, particularly the light gases, hydrocarbon gases, as a fuel source to drive the process.
Can I react on that?
Please, Han.
Positively, please.
Michel. First of all, I would like to give Rob a compliment for the fact that he has shown in his presentation the many steps which we need to take to get a recycled content product. And I think a lot of people in the general public have very little understanding of all these process steps. And if I have listened to the discussions until now, they're all highly technical. And I think for most people in the general public, they're a lost cause, because the knowledge which is being required is at such a high level that it is very difficult to explain in normal terms. And we have seen that also from Daryl's presentation, that it is not easy to explain. And I realize also that there is IP involved with all these questions. And a lot of people don't understand that either. They just think about plastic, and plastic is plastic, and plastic is rubbish and trash. And the other part
How dare they?
forgotten. Yeah, I'm
Yeah.
strong about that, and it shows how much education we still need to do in general, in the public, and in Australia, to make sure that people understand that if you make a food court in a university free of plastic, that you're actually doing the wrong thing.
Correct. Yeah. Yeah, absolutely. I tell you what, though, if we took one of Daryl's 7-layered or 9-layered bags and we put $100 note in there and showed it to somebody and say, this is the value of plastic, it would certainly change their opinion.
That's right.
Look, I think that brings us to a conclusion. So thank you to all the speakers this evening, to Daryl, to Rob, and to Haroon. Wonderful presentations, and thank you to everybody for contributing to the discussion. I'd like to also thank the organisers, so the RACI in conjunction with the SCI and the SPE, tireless efforts of Han and Yvonne, and thank you to our sponsors, RB, BASF, Qenos, Foundry, and thank you to all our participants who have joined and continue to join these excellent set of episodes and presentations. We thank you all for joining, and we hope to see you on our next episode. If somebody can remind me what that is. And also something
Sustainable
has,
solutions.
that's the one. And I believe this week is Australian Made Week. We're celebrating anything Australian or introducing Australian Made Week this week. So go out and buy something Aussie, eh?
Yeah.
Propylene and polyethylene.
Aussie plastic.
I'll go get that Kitkat tonight, I reckon.
Made of plastic.
Have this one.
Yeah.
Ah,
That's
that's a good one.
after that, I'm feeling a bit peckish. Thanks, guys. Good night, everyone.
Thank you.
Thanks, Dave.
Thank you. Bye.
Bye.
All the best.
Bye-bye.